Circles by Rosalie. So the first thing that you need to know about circles is the standard equation. That's this equation right here. This equation basically gives you everything that you need to know about graphing a circle, which is the radius and the center. So you can see that r equals the radius, h equals the x-coordinate, and k equals the y-coordinate. The only thing that you need to look out for, though, is that the coordinates that are graphed in the circle are opposite signs of what's here in the equation. So you can see that negative h equals positive k, and negative k equals positive k in the circle. The next thing is graphing a circle from the standard equation. This is pretty simple because the problem is already in the form that you want it in, which is the standard equation form. So here's an example. You can see that the center is 2 and 4 because those are the coordinates given right here, and you just flip the signs. So you get negative 2 turns into positive 2, and negative 4 turns into positive 4. With the radius, you can see that r squared equals 25, so the radius equals 5 because the square root of 25 is 5. If you were to graph this, it would look something like this, where you come up to 2 and 4, and the radius equals 5. So you come out 5 units. Pretty simple. The next thing is graphing a circle from the expanded equation. This is a little bit more difficult because the problem is not in the form that you want it to be in, so you have to put it into that form, which is the standard equation form. So the first thing that you want to do is you want to add 17 over, so it looks like this, and you want to group all the like variables together so that the y variables are with the y variables and the x variables are with the x variables. Now you want to complete the square for both sides of the equation, both the x side and the y side. There's two ways to complete the square. There's the long way and there's the shortcut way. So for the x side of the equation, I'll show the long way, just so you know how to do it. So first thing that you want to do is you want to find half of the variable before x. So half of 4 is 2. Then you want to square that answer that you got. So 2 squared equals 4. And you add 4 to the end of the equation. So 17 plus 4 equals 21. And then you want to turn the x side of the equation into square form. So you take the answer from step 1, which was 2, and you add it to the x coefficient and square it. So you get x plus 2 squared. And then you sub this in for the x part of the equation. So you get x plus 2 squared plus y squared plus 4y equals 21. So now you've completed the square for the x side of the equation, and you need to do it for the y side of the equation. So here's the short way to do that. So here's your problem. Again, you want to find half of whatever's in front of y. So half of 4 equals 2. And you know that you can sub 2 in to form a perfect square, so you get y plus 2 squared. And you sub that in for the y side of the equation. And now you need to balance the equation. So you find 2 squared equals 4, because you got 2 from here. And you add that to the end of the equation. So you get 21 plus 4 equals 25. And your answer is x plus 2 squared plus y plus 2 squared equals 25. And so this is in standard form, so you can get the center and the radius from this. You can see that the center equals negative 2 because you switch the signs, and the radius equals 5 because the square root of 25 is 5. And if you were to graph that, that'd look something like this, where you come down to negative 2, and you go out 5 units all the way around the circle. So the next thing is finding the radius when given a vertex and center. So here's an example, 3, 3, and 6, 4. The first thing that you want to do is you want to graph this so that you get a general idea of what it looks like. So here it is. And the radius, which is what you're trying to find, is the distance between 3, 3, and 6, 4, right here. So how do you find that? Well, you know this x distance here, and you know this y distance here, and you know this x distance here. So you can make that into a triangle. So if you do that, it looks like this, where you're trying to find r. So since it's in triangular form, you can sub that into Pythagorean's theorem in order to find r. So if you do that, it looks something like this, where 1 is A and 3 is B and R is C. So you get R equals root 10. And you don't need to simplify root 10 any further, so root 10 is your answer. That's the end.